Hi, I'm Buck Woody, an applied data scientist here on the Azure data team.
I'm Melony QIN, a program manager at Microsoft on the Sql Server Big Data Clusters team.
And we'd like to welcome you to SQL Bits and the Administrator's Guide to SQL Server Big Data Clusters. Let's get started. Okay, before we get started learning the tools and processes you need to administer a big data cluster, you need to understand the components within the big data cluster. It has database servers, Spark, and so on, and it rides on a complete platform all by itself. So there's a lot of moving parts here, and you need to understand the terminology we'll be using. Now, this is a refresher, so if you're unfamiliar with these terms, if you don't know what a container is and you don't know what the Kubernetes is and all the rest that we're talking about, pop over to the full course we have available to you out on SQL Workshops. And if you go to that site, you'll notice there's a couple of courses that you can use. I'd recommend the architecture course for big data clusters to start out with. So we'll assume that you understand what a container is and what Kubernetes is, but we'll talk about the parts that we're using inside big data clusters. So first, a container is just an abstraction to run protected computing space. It's not a virtual machine, but it accomplishes much the same thing in a lighter way. And it's all driven by a series of files. In fact, all of the big data cluster is driven by a series of files called manifests, and they're YAML, yet another markup language files, where you define what you would like, and then you tell the system to go implement that. You can lay down Kubernetes locally on your infrastructure there you have in your area, or you can use a service like Azure Kubernetes Service, Red Hat's OpenShift, or other clouds as well. We'll mention more about that in a moment. But at any rate, we assume you've got a Kubernetes cluster running. A Kubernetes cluster involves basically just a few things. Number one, it's a series of containers running. And then when you group those together into an abstraction, that's called a pod, P-O-D, a pod. And it's just a logical grouping of containers that will always be kept together no matter where they run. Now they need to run on something, and so this is called a node, and a node is just a computer, and you can see that illustrated with a hexagon is the way that Kubernetes documentation lays this out. A node can be a physical computer, or it can be a virtual PC. The point is it's a full operating system, usually Linux, and in this case it is Linux. Now we need a way to protect our storage. We will be running databases and so on. So if we were to store our data inside a container, that goes away when the container stops. If we were to store it inside the pod, that goes away when the pod goes away. If we were to install it on the node, if we were to put storage there, that could be a problem if the node fails. So there's a concept of volumes, and in specific the persisted volumes, is a series of durable storage that's mounted to the pod via something called a claim, and that claim is just a key that allows these things to talk together so that if the container, pod, or node were to go away and come back, which is one of the things that Kubernetes will do for you, it will automatically reclaim that volume and begin working again. So you have a momentary blip while it sort of remounts the storage, and off you go. Putting all of this together, you have a cluster. Okay, well, that's the basics. Again, if you need a more thorough explanation of containers, Kubernetes, and so on, we've got a full course for you available in SQL Workshops. Now, when you begin to install SQL Server Big Data Clusters, we're going to assume you have Kubernetes somewhere. You will point us at that using the installation procedure. You will lay out the YAML files the way you want them. And once that's done, it will begin to lay down certain components. And the first component it lays down is something called the controller. And this is from the SQL Server side. It then wakes up a few other services. I've got them illustrated in a single bundle here, but it includes things like Grafana, which is a graphical tool you'll see in a moment for monitoring, Grafana, a log collection tool, things for Active Directory integration, and more. It allows you to collect the health of the system. Once all of these are running, it begins to lay down the rest of the components. The first thing it lays down is a SQL Server instance, and this is the main one you talk to, and all of these are talked to by something called endpoints, which are just ports. on a TCP/IP address. The default one here is 31433. You remember 1433 from the SQL Server days? Well, now it's 31433 to be inside of Kubernetes. Now I've got these illustrated in certain nodes and pod arrangements, but that's in no way meant to say this is the way it's arranged. You lay that out inside your file once you've done your architecture work and your sizing and so on. And we can see that we've got the main databases and LDFs and MDFs and all that on a persistent volume, so that if the system goes down, it will come back, remount, and start back up again. This is the primary place that you talk to everything inside the cluster. There's another series of SQL servers in the compute pool, a logical boundary. Once again, I've got it on its own node, but it could be on multiple nodes or on the same node or different ones. This is a series of SQL Server instances that offload some of the poly-based work for the primary instance. You don't talk to it. It has an endpoint, but not something you'll talk to directly. So this is sort of a compute offload, if you will, for that. Now for scale out or up data inside relational data inside the cluster, we have the SQL Server data pool, and these are a collection of more SQL Server instances. Once again, you don't talk to them, you talk to the primary instance. It will talk to the compute pool, and the compute pool will handle talking to the data pool for you. These are round-robin databases that use the data management, data migration service, or rather data movement service, and so on to communicate across the cluster. Another very important set of components is the storage pool. And the storage pool contains three things. Another SQL Server instance that you once again don't talk to, but it allows direct communication to HDFS, which is the next component, files. And the HDFS is the Hadoop distributed file system, and this lays out files in a distributed fashion and then brings them back together when you query them. So now you can create a table, it's an external table in SQL Server Master. When you ask for data from that table, it will walk from the compute pool to the SQL Server down to the files that the HDFS system is storing. You can also work with those files with the Spark subsystem, and that's the other big piece that you'll see inside the storage pool. Some people get a little confused about data pool and storage pool. Easiest way to remember it is data is database, and pool, storage pool is storage, which is just regular files. So that's the way that works. These will have an endpoint as well. The Spark system and the HDFS name node will have an endpoint you can talk directly to. So primarily, you'll talk to the SQL Server primary instance, the Spark, and the HDFS independently, along with some of these shared services like Grafana and Kibana. Those endpoints are well defined inside the documentation, and you'll see how to list those shortly. Okay, now we're to our final component, and that's the application pool or the app pool. This is empty when you first start, but you can deploy things into it that can be containerized, and one of those could be perhaps the Microsoft's machine learning server. So you could offload some work that way, perhaps an SSIS job, or maybe even a Flask application to do scoring and so on. This keeps your applications inside the same security boundary and management boundary. So this is our architecture. Once again, this is new. You want to pop out to that course, take a look and read the references there. Everything's free, and there's lots of emulators for you to learn these concepts before you move on. Well, now let's take a peek at the tools we'll need on your workstation. We normally don't work from the server, just like in any standard SQL instance. We normally work from the workstation. So let's take a look at how we do that next. Now, when you're setting up your workstation, you'll install quite a few tools. I've got them listed here. We'll pop in and out. There's a page for this that you'll find inside the installation documentation. Once again, I'll refer you back to that course, which will point you to all the links that we have here. They'll also be inside your PowerPoint slides that you'll get from this event. But at any rate, there's a few tools that you do need to install, and they're listed on the installation documentation. Let's run down each one of them and what they do, and then we'll assume you've done that and go from there. The first is Python. And Python, of course, is a language that we can use for lots of things. Started out as a scripting language and now has become so much more. And we use it for almost everything within our big data cluster. In fact, it forms the foundation for some of the other tools that you'll install. The next is a utility, once again, run through Python called AZ Data. And this is the tool you'll use to interact with for the cluster itself, for the big data cluster, not the Kubernetes cluster, although it uses the tools for the Kubernetes cluster as well. So this will deploy the cluster, we'll show you the health, the logs, and so on. We're going to see lots of those in the next topic here as we go through this. And you'll also need to make sure you have that set in your path. The documentation itself explains how to do that, but you'll want to be able to type AZ data from wherever you are. Now, it should be noted that if you use the SSH, Secure Shell Protocol, to talk directly to the cluster itself, the nodes or pods or even the containers on the cluster, they may or may not have the AZ data in their path. We're talking all on your workstation, which is separate from the server. To be able to do that, you need to authenticate, you need to connect, and so on with Kubernetes. And to do that, we use the command line tool for Kubernetes called kubectl. I pronounce that kubectl, which some folks find hilarious, but it's kubectl or kubectl, whichever one you like. It's kubectl though. So to do that, however, you need to have the key that allows you to talk to the cluster. Think of the name and password that you need. This is held in a certain file on the server, and if you go to the main node there on the server and you SSH to that, and you go to the home directory, if you're in Linux, that's going to be your home directory, and then you go to a hidden directory called .kube, and you change directories into there, there'll be a file called config, C-O-N-F-I-G. The config file contains all of the secrets and the keys that you need to connect. I often copy that file to the location, same thing, wherever your user's directory is. In Windows, it's obviously your username, and then .kube, and copy the file there. And if you do that, it'll just magically wake up if the TCP/IP addresses and so on are linked correctly. So once you do that, the kubectl command, if it's in your path, will read the context out of the file, the config file, and will connect over the TCP/IP address noted there, and that's the way that works. So once again, we need Python first, then AZ data, then kubectl. And then finally, I use the Azure Data Studio tool for pretty much everything. Now, when you run that tool and you connect to it for the first time to a SQL Server Big Data Cluster, you'll see some things download automatically, the add-ins and so on. The extensions that you need to make it work will all be there. This will provide your management surface, some of your monitoring surface. It'll provide the ability to query things, to run notebooks, and so on. We'll stay in that tool for the rest of this session. Even the command line tools, I'll just use the terminal view from here on out to be able to run the kubectl commands and even the AZ data commands. There's actually one more area of security we need to talk about for a moment. To use many of these tools, you need to be able to authenticate to those endpoints I mentioned a moment ago. Melony, why don't you show us a quick demo of how you can set up those endpoints using the notebooks we mentioned inside Azure Data Studio.
So now we are in Azure Data Studio, where you find a bunch of executable notebooks to help users managing and operating big data clusters. In the section called Certificate Management, we have run the notebooks to manage certificates on big data clusters endpoints. As Buck mentioned in BDC architecture diagram, there are 5 cluster endpoints to the big data clusters we need to install certificates. For instance, we have a master instance endpoint for accessing Sql Server master instance, a gateway endpoint, also called NOX, for accessing like HDFS files and Spark. Also, a controller endpoint, which is the entry point of cluster management service to manage the cluster. Then, a management proxy endpoint to access the Grafana log search dashboard and Grafana monitoring matrix dashboard. Finally, application proxy endpoint for managing applications deployed inside the big data cluster. You know what I loved about here? You have a notebook to help resolve all those challenges easily. No need to install certificate one by one unless you wish to. What you need to do is to click the button and the notebook will take care of the rest. Just for the interest of time, let me show you real quick what we expect after notebooks finish execution. Let me open my browser, go to my Grafana dashboard. As I mentioned earlier, Kibana and Grafana dashboard are under Management Proxy Endpoint. Let's have a look here. Now we can see a certificate is installed.
Now, the final thing you may need to install is the Azure CLI, command line interface, or another interface if you're using a different cloud provider. Let's assume you're using the OpenShift system. You will install the OC tool and other tools. That will be dependent on the cloud provider if you are running on a cloud service. If you're not running on a cloud service, you won't need these. There are some optional tools you can install as well, the SQL command line interface and so on. But in general, these are the only tools you need to install and configure on your local workstation. Now let's get started on using them. All right, now we've got a good understanding of how everything works, and we've got all our tools installed and our configuration set up, so we can now talk to the cluster. Let's now talk about the tools and processes we use to get basic system information, and then we'll dive into these topics a little deeper throughout the rest of the session. Well, the first thing you might do is set up any kind of logging that you want to do, and there's a lot of ways to do that. Grafana and Kibana that you'll see shortly have their own features to collect data. They're actually collecting into a series of databases, some Elasticsearch databases and some FluentBit databases and so on. So you can query those directly, or you can save those logs out. But when you do sort of your morning checks, if you will, you might want to set up logging. The reason we don't tell you what kind of logging to do is because you've got multiple ways to look at your system. If you're using commands, you could pipe those to a file. If you're going to use notebooks, notebooks can be saved and the results stay with the notebook, the Jupyter notebooks. So that's another way you could maintain your logging. Or you probably have a centralized logging system where you're checking your systems each day, and you'd actually like a broader view than just the big data cluster. So we're going to show you all the tools, and then you figure out the way you want to do logging. So that's the logging side. The first set of things we need to work with is the actual AZ data commands. This is the thing I told you about earlier, the utility that you can use to interact with your cluster. I'm just here in a PowerShell terminal. After you install the utility, you're able to use that in a CMD or PowerShell or even the terminal inside Azure Data Studio. I'm just going to leave it here for the screen's sake so we can see things a little better. First thing we need to do is just make sure it works. So I've just typed AZ data version here, and it gives me the version I'm currently at, and I literally just before doing this made sure I was sort of up to date. The next thing we'll need to do is we'll need to sort of update, or rather log in to the cluster itself. And you can see here's the way this works. AZ data is the command, then there's the login, then you set the endpoint, and for the controller, it's the same IP address as everything else in my case, but the controller has a specific port 30080, and then when I installed big data clusters, there's username admin. Now of course you're asking yourself, wait a minute, you're going too fast here. It's fine. I'm going to put the links in the documentation or in the notes view of the PowerPoints so you can find everything I'm typing. It's all on one page. So don't fret about recording this. Just take a quick peek on how this works. So the first thing we'll do there is we'll try to log in. If my cluster is up and running, it'll be ready to go. It's going to instantiate some things, and it's asking me for my password. So I'm typing in my password here. Now, remember I talked about the kubectl command earlier that we'd be talking to, and we'll talk about that more in a moment, but it actually uses that command to connect to the cluster. And you can see when I installed, I picked the name MSSQL-cluster. Well, actually, I didn't pick that. That was the default, so I'm going to do that there. Now, the first thing I'd like to do is I'd like to get those endpoints that we just talked about. So the first command I'm going to show you after the login itself is the endpoint list. and I'm going to go ahead and output that as a table, and we'll take a look at the at what we get returned there. And you can see kind of where we're at. So the neat thing is with this table view, you actually see on the left a nice description of everything. And there's all of our endpoints and the name of those endpoints, which is kind of nice, tells you everything that's there. There's 3 or 4 that are very important. One is the controller, which is 30080. You can see cluster management service down there. The SQL Server master instance is the next big one here. Same IP address in my case, because I've installed it on one location. And the number is 31433. So you can see the rest. Kibana, Grafana, Spark, and HDFS are the other ones. Let's take a look next at getting our status. Now, once again, you could be piping these out or even including them in a notebook to do all this work, and we'll see that later. But I'm just going to go ahead and get the cluster's status with AZ Data BDC status shows as big data cluster. The wonderful thing about this particular output is it's in color, which I really like. I just quickly look, and if it's green, we're good to go. It also has the words in case you don't see green or you're on a terminal that doesn't output the storage or the colors. But remember we talked about those pods and nodes and services and containers. Well, here they are. So we can quickly see there's my data area, there's the storage, remember that, the SQL storage, the compute, and the master SQL Server instance. Here's my HDFS. We've got our name node, the storage, and the Spark head is there. There's my Spark services, the control system area that we talked about, metrics and so on, and the logs, that's Grafana and Kibana. So that's everything there. Now, what if you just care about one of these? Let me grab one real quick. I'm not typing during a demo because I don't trust myself to do that. Some people are very good at that. I'm not one of those people. So in this case, I just want to see the status of the SQL Server portion, and it shows me every part of just the SQL Server portion. So it carves that up nice. We've also got one for HDFS and so on. Once again, that command, and all these are listed for you. All these are listed for you here, is a SQL status show, AZ Data BDC SQL status show. And there's all. Okay. The next thing I care about a great deal is storage. This one I care about a lot. Let me just clear the screen here for us. Just so we can see this one. What I'm going to do is I'm going to go get all of the storage that I need here, the information from the storage with BDC status show all. And the resource I care about is the storage section that I've carved out on this particular cluster. And you can always do the -- help and so on to find out more, but I can quickly see if my storage is healthy. Now you're probably asking, wait a minute, what about how big the storage is? Well, we're going to take a look at that in another area. The next thing I might care about is the control information. So once again, not typing, just copying all that. So we pop over here, and now we can see the status of the controller and if it's healthy. And this shows all the different portions of the control surfaces. Once again, more in the documentation. The final piece I care about a great deal are the logs. So let's go take a look at the logs. Let me clear, actually. Let me just clear the screen on that. I should have just hit Control C, but there we go. There we go. That's the status, because I didn't hit enter. Sorry, I'm moving too fast here. Here we go. I want the logs of the system, and I want to copy them all into my temp directory. So AZ Data BDC debug. It's a command we use to kind of peek into the cluster itself, and there's a command within debug called copy logs. The one I want to get is the SQL Server cluster, the one that I built when I installed, and the output I'm going to send it to is SQL and temp. Now this will take a few moments to run, but basically it's going to walk through and get all the logs from everybody and dump them in a single location. So we won't wait for that to complete, just going to show you kind of how that works. Let's pop over to our next topic here. Now let's go take a look at the Azure Data Studio tool itself and what it can provide from a system information standpoint. Okay, we've connected to our Azure Data Studio now, and then all I do is make a new connection to my big data cluster. Let me just click on this for you so you can see what mine is. It's a SQL Server is the way you connect to it, and then remember you've got that port there, and it's with a comma, not a colon. Kind of interesting to think about when you're doing that. I'm not using Active Directory authentication in this case. So we're going to use a SQL login. Admin is the name I chose, and I put the password in, and you can give it a name and so on. So here we are. I'm inside the big data cluster. If I just double click it, it's automatically going to bring up sort of that properties panel on the right to let me administer the system a little bit. Let me hide my terminal here for us. And here's another place you can quickly get information about the system, and there's lots of other commands you can do. But what I want to pay attention to in specific is double click on this big data cluster area down here, and then I can see all of my endpoints here. I can connect to things and I can copy those. So Azure Data Studio, along with being able to run commands and notebooks, can also show me the output of my cluster and whether it's healthy or not. I can also explore it like you normally do in any sort of object explorer there on the left. Let's take a look next at the notebooks that are inside the Azure Data Studio tool. Well, there's a series of notebooks we've put together for you inside Azure Data Studio, quite a few of them actually, more than we're even able to cover here. But I'm just going to introduce these to show you where they are and kind of the groupings that they have and how you can use them. Let's pop over to Azure Data Studio and take a look at those notebooks. So here we are back inside Azure Data Studio. Let's take a look at some of the notebooks we've provided for you. Now you can make your own, but we've given you a few. I'm just going to click on SQL Server 2019 Guide. And when you do that, you'll instantly come to these provided books here. Let me sort of bring these up for you. I'm just going to give us a little bit of screen real estate here. We're in the welcome page. And you can see that there's quite a few notebooks we give you for all kinds of things. And once you open them, let's say monitor big data clusters. So there's the controller status. Now, you remember all those cool things we did in the AZ data commands? Well, here they are actually. There's the same thing we showed inside the Azure data commands, but you can show them inside these notebooks. And there's quite a few. Just come to the welcome area once again, and you can see what each of the groupings sort of are for you. And they're used for lots of things, from controlling the way the system works, but in our case, in monitoring the system. And the outputs can be saved as notebooks, and you can store those in your source control system or your logging system. Well, that's a fascinating thing that we've got there, and you may say, well, I want that logging and I want all these checks, but I'd like to do it in notebooks and I want to automate it. Well, I've got a line down here at the bottom that gives you an example, and this is fully documented for you, but it gives you an example of automatically running a notebook and persisting the output for you so you can see the results. And once again, this is done with our AZ data command. Well, this is system information. Let's move on to our next topic.
Monitoring is essential across today's complex computing environments. When it comes to BDC, we provide multiple ways to help customers get an end-to-end full-stack monitoring experience. By saying that, we have documentation articles to give customers a high-level guidance. Integrated with Azure Data Studio, one of the greatest tools for data scientists and data engineers with insights from the dashboard. Consolidating those monitoring metrics into a unified Grafana dashboard, virtualizing the logs from the Kibana dashboard. So, the best way to explain this is to jump into a demo. So, as I mentioned, the documentation is always a good start point where we're giving some useful guidance to the customers. You can choose the most appropriate options for you from here. What we recommend is to go to Azure Data Studio. In the first place, we get general information here from the home page. From the database blade, we can check the basic status, size, and last backup time of each database. And from BDC Blade, we can find the endpoints we can use to access, such as Grafana dashboard and Kibana dashboard. Let's look at Grafana dashboard out here. As I mentioned, a full-stack monitoring experience basically is to provide 3 different levels, from BDC cluster level, node level, and application level. So if you go to Sql Server Matrix page, you can find a metrics and statistics such as transactions per sec, and gain insights about database activities. From the host node matrix, you can check metrics such as CPU and memory usages, and even more insights about your disk performance. And go to the apps matrix, you can find more insights about the apps that you deployed inside the big data cluster like I did. And you know what is even more valuable? It also helps us to understand the resource consumption such as CPU, memory, disk, and network usage on a single container level. Similarly, if you go to Kibana dashboard, we can also get a page where we can virtualize all the logs collected by Elasticsearch. You can check the log for a specific container from Kibana dashboard. You can also check the logs for a specific period from here. Let's go back to Azure Data Studio. We can find a few sections of notebooks. We have notebooks to get more insights for Kubernetes Cluster itself, where BDC is on the top of it. And even for Kubernetes objects such as persistent volume or replica set, we can get insights from here. We also have notebooks to help you understand the status of different components of big data cluster, such as what's going on in your Spark sessions, or what happened to your HDFS storage. So, to wrap up, always start from documentation to find the best way to go. Take good advantage of your Grafana dashboard and the notebooks that we've provided with Azure Data Studio.
All right, the next most important topic is security. It's all about security inside the big data cluster. We're going to cover 3 things a little briefly here. There's a lot more information down in the documentation, and you should definitely check out that documentation to read through this. It's not complicated, but it is complex. There are a lot of moving parts. Keep in mind, you're securing lots of things. So in general, you're going to have the standard SQL Server security surface area, and you're also then going to have other surface areas. So I'm going to point you down to that tiny URL there, and we'll come back to that in a little bit as well. There's a video there, all kinds of things that you can learn more. Okay, let's talk first of all about the surface areas we're going to work with, and then we'll talk about the security mode that you can work with, and then we'll move down to the actual endpoints and so on. Let's get started. Here we go. The first part we need to think about is basically everything we've been showing you so far. Now, we've been showing you tools and methods. In a bit, we're going to talk about troubleshooting, which involves a process. So we're going to add in the tools and the methods. Let's stick, though, with the components that we're dealing with here, and also then with the tools that you use to manage those. Then we'll talk about how you use those to secure the endpoints, okay? Are you following so far? Good. All right, let's take our Kubernetes cluster, and remember, this is dependent now. If you're using OpenShift, or if you're using some other cluster, if you're using Azure Kubernetes Service, they will have security aspects as well that you'll need to be familiar with. But we'll assume for the moment that this is plain vanilla Kubernetes, just installed locally is fine. So the first part we'll talk about is the tools that you use to work with security for deployment, configuration, upgrade, and your high availability. Now, the first of those is kubectl, kubectl, that you use. And those commands, which we've talked about briefly before, and we'll talk about a little bit more as we go forward in the notebooks, works with the Cluster Orchestration Manager. This is a Kubernetes artifact. If you're using an OpenShift, there's a layer above that. If you're using Azure Kubernetes Service, there's a layer above that, and so on. We talked about earlier copying the config file over so that you can talk to this. Now, that's not a completely secure process. You don't want to just be copying these files randomly around onto people's computers. Those need to stay secure. That is a self-encrypted file, or non-encrypted file, I should say, with a self-signed certificate code that will just go out and talk to the cluster. So you want to protect that at all costs. That's your config file in .kube. So hopefully you remember when we did that little copy routine there. There's actually a better way to do that. It's documented inside the kubectl command documentation. It will allow you to authenticate to a cluster. And one of the things we didn't talk about but need to mention here is that then we'll create a named context. And then when you connect it to something with kubectl, you can set the context. We're using the default context, in fact, the only context that was in that file, but you could connect to multiple Kubernetes. That's all controlled within that config file. So that's your first thing you need to concern yourself with. Now, we have a bit of a misnomer here going on. Kubernetes did not have the concept of controllers very early on. So when we were building big data clusters, we named the service that we use for things a controller. But in fact, that term is now overloaded because they've come out with a controller. So those now are a little mixed. So I've colored it in orange here. If you can't see the colors, it's in orange. Should be slightly lighter than the rest of the text, to indicate that that is a Microsoft supplied component, not a Kubernetes controller or operator. We had those kind of things going on. Okay. The two tools you'll use here are AZ Data, and we've seen that quite a bit lately, and then also Azure Data Studio. Now, it should be noted that the controller service is going to be listening to that command from AZ Data, and the command from AZ Data will often ride on top of or make utilization of the kubectl command. So those go hand in hand as they're working. The Azure Data Studio tool is using the exact same API. So underneath, just like in T-SQL, the algebraizer tears everything apart. It's all T-SQL all the way down. Same thing here. So when you authenticate, and we're going to talk about that in just a moment, these tools are used to talk to the controller. The controller stores a lot of data in yet another SQL Server database. It's actually a config store. This is another instance that you don't talk to. I haven't shown you this one yet. In fact, there are far more parts that you're going to see now that I haven't discussed already. In the config store, you can think of this is a terrible analogy, and I get in a lot of trouble for saying it, but it's useful mentally. This is sort of the master DB for this whole thing. So just think of it that way. Now, that's not a one-to-one mapping, so don't carry that analogy too far. I'll get in trouble and you'll get in trouble. We also have a thing called a control watchdog that watches the controller to make sure it's up. So kubectl has its own, or rather Kubernetes has its own high availability constructs. So does our cluster, meaning the cluster itself, sort of keeping everything healthy. All right, I think we've done that one. Now here's I'm sorry, this is the overloaded term, not controllers, but operators. My bad. So the operators we created are in orange because we made this operator, but it's not a Kubernetes operator, not one-to-one mapping at this time. Okay. So this is the tools you'll use to talk to and the things that are involved in keeping all of that healthy. Just another part of the picture. We're not to the security yet, but this is involved. Now, on the monitoring and metrics side, remember, these are disparate, different pieces. So they're going to have different tools and surface areas and processes they use. So we try to bundle all that up, and we do that with a couple of tools that you've seen and you're going to see. And these are Grafana and Kibana, which are themselves platforms and tools that work with things. They have an interface. It's a web interface, and we'll see how you can make your certificate so you don't have to bypass your security to talk to those and so on. They talk to something called a management proxy. That's in orange again, if you can't see that color, because Microsoft built that. And this talks to, let's start with Grafana. Grafana is a UI, a user interface, that shows metrics that are being fed from somewhere. And it can work real time. It's an amazing tool. Love it. As I've been working with it and using it, it's just a fantastic tool. You can use it for lots of things, and you can expand it, and you can create dashboards and all kinds of cool things. But Grafana, if it were real time and the system went down, you wouldn't know what happened to a component if it's not running. So we have another thing running inside the pod and the node called Influx Db, a very small database that then is talked to by every other node and pod on the service, on the entire cluster. And those have two little widgets inside, one called Telegraph and the other one called Collect D. These are daemons or services that are running on each pod and node and so on. And those are popped up into the Influx DB, and then Grafana reads from that. Hopefully this is clear. I had to develop this diagram for myself to kind of figure out how all the parts are rolling together. Now, Influx DB is it's a good streaming database, very tiny, and it lets things go in just adding to the tail of the log constantly. It doesn't have high redundancy or anything like that because it doesn't need it. So that's why we're using that there and not just another SQL Server instance or burdening another SQL Server instance with that task. Now, Kibana is the logging interface, very similar to Grafana, but for logs. And so you can probably imagine what's happening here. We have a different database service called Elasticsearch, and this one is really optimized for finding things, and you can see why. In Grafana, you'd want to know sort of what's happening right now and go back historically and look at things. With Kibana, you would really rather be able to search the logs of anything and look for the word error, for instance. As you can imagine, there's a couple of little daemons that are running, again, called FluentBit, that will run down and grab the logs, turn those into streams of data, and shove them into Elasticsearch, and Elasticsearch talks to Kibana. There you go. Again, a little complex, but hopefully this diagram helps you kind of understand the parts that we're going to secure. Now let's talk about those parts. Here we go. All right, here we have our administrator, and she wants to administrate the system. Now you've noticed I've put the BDC security docs link back up in the top. You're going to need to go. There's a video in there. It's great. So just go watch that, and you'll learn a little bit more about what I'm saying here. But once again, I've laid out the parts here, and don't worry about them. I'm going to bring them in as we talk. So there are two modes that you can work with. The first is just standard flat security, and it's not really meant for an enterprise. We kind of expect you to have Active Directory running around somewhere, although you can use it without. SQL Server is SQL Server, so you'll be able to use it the way you're used to using it. But here we go. So when she logs on, the first thing she can do is she can run kubectl commands. That will have a name and a password. It's not a password, it's in the config file. So she'll need access to that information. That's agnostic of the rest of the cluster. Think of this as the Active Directory domain administrator account, because that's what it really kind of is. It allows these things in. Where did this come from? Where did all these passwords and things come from? Well, when you install big data clusters, that's where it went, right? It went right there. Okay. You created the name and password. All right, now, she also authenticates to Active Directory, as we said. Now, Active Directory will do its typical Kerberos stuff and get a getting ticket, and all the other ticket, blank something tickets that it does. It's a whole world, but it does all that stuff, thankfully, a bit transparently for you. It will get a token. That token will be used to talk to the controller we mentioned a moment ago. So when she tries to do anything inside the controller, she can do that through Active Directory. Now, if you don't have Active Directory and you're using the standard authentication, it's the name and password, and usually those are mirrored. So whatever you put for the administrator name and password for the cluster, same thing here, and that's also the SA account, which we don't light up. We actually put all those things together if you're not using that. At the same time, that same token is used for her to talk to the master instance in SQL Server. So when she logs on, she does it the same way she's always done. Names and passwords come from Active Directory from there on. SQL Server is SQL Server is SQL Server. Now, it is SQL Server on Linux, so you'll need to be careful with that concept. Now, this is where things get super interesting to me. HDFS, the Hadoop Distributed File System, is based on a POSIX subsystem, which is what Linux uses. So they have what they call mount points. In fact, everything in Linux is a mount point, even memory and your USB mouse and so on. It's very odd. Everything's a directory. Goes // right? You've seen those / guys. And they have ACLs, or access control lists, ACLs. And these ACLs are very similar to the windows that you may have seen, and they've got, groups, and they've got users, and they've got all that. So how in the world does that map out when SQL Server wants to mount those HDFS files we talked about? Remember how I showed you how it mounted into the HDFS system, the files that are there? How in the world does it map those things out? It was very clever. Database master key is used to go set the ACLs down here, and the ACLs then are then routed from or out to HDFS and then back through, and the DBMK is the thing that talks to that. Again, a lot more information in the security. Luckily, you don't have to worry about a lot of these guts, but you do need to know that they exist. That's probably the most complex thing you're going to have to mess with. Let's talk now about monitoring and sort of how that gets over let's talk about Spark first. Let's do that. In Spark, whenever you're talking to a Spark instance, you can secure Spark directly, but we don't want to do that. What we'd rather do is have a job management system, yet another resource node that will hand out jobs to Spark clusters as they need to work. To do that, they need a job system, and there's one called Livy, Livy, that's able to hand yarn jobs out, that's able to hand work to Spark. And to secure Livy, there's an open source product called Knox, like Fort Knox here in the US. And so the Active Directory token talks to Knox, that can now talk to Livy, that can now talk to Yarn, that can now talk to Spark. Now you see why I mentioned in the previous slide the information about all those where everything's going to hit and live and so on. So that's kind of the way that works. All right, we got one final piece. Now we can talk about management or monitoring. The management proxy, as I showed a moment ago, will use the same authentication. So again, you're not having to make names and passwords for all these things. You're able to hit them through Active Directory. And again, we're going to go through Grafana and Kibana for that. Okay, that's a whole lot to look at. So most important thing is this: know your surface areas, the parts we talked about. Remember the endpoints we talked about earlier, because those are how you'll connect to things. Those are listed in all of your management and monitoring tools that we've shown. AZ Data Command, Azure Data Studio, all those things will show the lists of IP addresses and ports inside your cluster. And then this portion here, know your mode, which is Active Directory or not. You really want to bias toward Active Directory. And then your final thing you want to think about is this diagram here, and walk through this. You're able to pull these decks down, I believe, and so just walk this one at a time, and it will begin to make sense as you trace things through. This will also help you with the logging. When you see so-and-so attempted to access so-and-such, you'll be able to find out who did what from here. Okay, that's a whirlwind of security. It's all we have time for right now. And then you can dive deeper in the documentation there. Let's move on and talk a little bit more about another process after this.
So having a good understanding about what's going on in BDC cluster is to set up the groundwork to dealing with a potential issue proactively. Apart from a set of monitoring tools that we mentioned earlier, we also provide a pack of troubleshooting tools to help our customers. So the following demo, I'll take you through the end-to-end approach to understand how to identify the actual issue, as well as how to troubleshoot them. So we highly recommend our customers to go start from the documentation articles. Quite often, we first start from the cluster level to understand whether the problem is more related to BDC or to Kubernetes itself. You can find some useful kubectl commands to help you out depending on your specific use case. For some security-critical customers, they are working with BDC in Active Directory mode as part of their enterprise-grade solutions. You can find how to troubleshoot issues related to on-prem Active Directory here with automation scripts. And more troubleshooting guides such as issues related to HDFS or other components will be coming soon as well. So go back to Azure Data Studio. We could apply the same troubleshooting pattern here. Start from getting a good understanding on what happened in Kubernetes level, container level, or anything else around Polybase with AZ data or kubectl commands. Then goes to BDC OSS components such as Levy, Spark, Elasticsearch, Kibana, or Grafana logs. Finally, we also have a section of troubleshooter notebooks to help you troubleshoot each component based on your discovery from the logs. So basically, what we recommend is to start from the host, which is Kubernetes in this case. Then dive into different BDC components depending on your requirements. Then you can have a roughly idea about where is the problem. Is it from BDC cluster, from Sql Server, or HDFS, etc. You'll find which troubleshooter is the best match for you.
Well, there's a lot to learn, a lot of parts in here, a lot of moving parts going on, but you can do it. We've given you lots of resources. There's notes in the PowerPoint slides, and there's references and so on. We really appreciate your time today. This is something we're here to support you on. Definitely follow the documentation. We do keep that up to date, and you're able to make comments on that, and we listen to those comments and update it accordingly. But we do update that documentation very frequently, so check there quite often.
Yes, thank you for listening. Make sure you check out the PowerPoint notes view for the links and other references we mentioned.
Thanks, Melanie. And thank you for listening. We hope you've learned something new today, and we can't wait to hear your experiences with SQL Server's big data clusters.